Okay, so the t-distribution, what's that? And what did William Seeley Gossett find? So William Seeley Gossett, as I mentioned in the last video, he was working for Guinness, same place that makes stout in Ireland. And they wanted to keep secret the fact that they used statisticians to monitor their processes. Very much how companies work today in manufacturing. In food, they keep people on staff that make sure the machines are doing things, making sure that brewing times are right, and so on. And he discovered this, that when you have S instead of sigma, that you have this slightly different distribution than the normal distribution. And it's called the t distribution, and it has n minus 1 degrees of freedom. Now keep those words in mind, degrees of freedom. Those are going to come back up to haunt us pretty much through the rest of the course. And he published under the name student because he had to hide his identity. All right, so the interpretation, by the way, before I leave this page, the interpretation is very much the same as a z-score. I mean, when you have a t-statistic that's like 3, it means roughly that you're 3 standard errors above the mean, or that your x-bar would be 3 standard errors above the population mean mu. Right, long and the short of it. Now let's look here. Let's see how it compares. So here's the z distribution. I took a whole bunch of random samples from the normal distribution, that's this, and then I took a whole bunch from the t distribution. Now, don't pay any attention to the width of the bars, that's not the important part, but pay attention to how much taller this is. Look, this one goes above 0.4 here. This one never reaches 0.4. It's got a shorter height at the middle, and then look at the tails over here. See how they've got stuff in them, right, like 5 and 6 and so on? But up here, there's nothing there. Right? So the long and the short of it is that the two curves, they have the same center, but the t curve is shorter at the peak and has fatter tails. And that's the big difference between a t distribution and a normal distribution. All right, then how do t distributions differ from each other? And you'd say, what do you mean? There's more than one t distribution? And I'd say, yes, exactly. So here's that same graph from before. This is when n is 5, so same one. And here's when n is 10. Oops, not there. There, come here. There he is. There's when n is 10. Like that. See? All right. So, and forgive me because I wrote this all before because I already made a video and the computer ate it again. So, but the one where 10, look, it's a little bit taller than this one. It's not as tall as the normal curve one. The normal curve one's still got more chops going on around here at the top. But when n is 10, it's taller, closer to 0.4, which is where the other one goes. And then you have a lot less in these tails. Look, over at the 5 and the 6, you don't have a lot there. So n is tall. When n is 10, it's taller than when n is 5, and it has smaller tails. All right. The portion that shows the t-distribution changes depending on, this portion, excuse me, shows the t-distribution depends on your sample size. And the answer is degrees of freedom, which is n minus 1. That is how it relates to sample size. And I'm not going to get too much into degrees of freedom. There's a whole philosophical and mathematical argument to what they are and how they work, and I really just don't want to get into it. It's long and complicated. But suffice it to say that, let me give you an example. If you had 5 different crayons in your hand, different crayons in your hand, and 5 people in the room. Oopsie. Sorry about that. That kind of, there you go. 5 people in the room. Then the first 4 people, get it? 4, which is 5 minus 1 equals 4. People have freedom. They choose which color they want. But the last person is stuck. In other words, when you have 5 crayons, or when you have a sample size of 5, for example, then 4 of the elements in the sample are free, but the 5th one isn't free. It has to be whatever is left. And anything more than that, I don't want to get into because it's just too complicated. All right, now what about the t-distribution? How does it look? Well, we already said it has different degrees of freedom, and there's a whole bunch of them. And notice that it's centered at 0, just like the other ones, just like the standard normal curve. And I'll keep talking about it in the next video.